Welcome to the second part of the lecture series on engineering statistics. We talked about basics of engineering statistics in the part 1. We talked about the kinds of statistics, the steps in having a statistical analysis, and we introduced you to statistical terms as well. In this part, I will try to talk about basics of descriptive statistics. As we have discussed in the previous part, what is descriptive statistics? It only describes the data, it helps in organizing, analyzing the data in the present form, but in a meaningful manner. We explain the already known data, limited to a sample or population, whatever we are trying to put, and we try to present the data in the forms of graphs or tables. Now, how do we present that in the terms of graphs and tables, and what are the general calculations that we do in descriptive statistics? I will try to go through in this lecture. First is measures of central tendency. I talked about the measures of central tendency in the previous lecture as well, when we are talking about the centering of the data. To what point is the data centered at? It could be based upon mean, mode, median, percentiles or quantiles and mid-range. Percentiles is about cent, percent. It is about 100 parts. Quantile is n number of parts. If it is quartile, it is 4 parts. This we will discuss. Let me first go through some terms in the measures of central tendency. Randomness is the most important term here. A random action is supposed to have happened by chance. If any item is more likely to appear in the sample than others, then the sample is not random. So, whenever we take any data set, whenever we are taking mean of any set of the observations that we are taking, we always consider that observations are taken at random. That is, one observation is not dependent upon the other. For instance, if I say the roughness value is 2.5 micrometer, I have been taking, this is as an average of the 10 samples which have been taken. All the samples are now considered to be completely random. If I take, suppose the sample manufactured first in the morning and sample manufacturing last in the evening, there could be difference depending upon the machine performance. So, then it does not stay random. It is, we have to give more weight to the sample which is there in the evening than to the morning. Then the kind of the mean we take there is not simply mean, it could be a weighted mean. Then mean, it is the arithmetic mean given by data, the sum of all the observation divided by the number of observation. This I will give you an example. Median is the middle term, middle value, that is median is the midmost observation. Mode is the value which appears the most in the given data. The observation of the highest frequency is called mode. The data may have no mode, one mode or more than one mode. Mode is equal to observation with maximum frequency. What is mean? It is the most commonly used measures of central value. It describes the average typical value in the data. Various types of means are arithmetic mean. Whatever mean, when you generally talk about the arithmetic mean, only you take the sum of the observations and divide it by the number of observations, that is arithmetic mean. Geometric mean. Geometric mean, in place of sum, we take product of the values. So, geometric mean talks about the nth root of the product of n number. For example, 10 numbers are there, we multiply it, then they take the 10th root of that, that is the geometric mean. Then comes harmonic mean. Harmonic means is generally the means of the ratios or means of the reciprocal of the arithmetic mean. When I say means of the ratios, the terms which have ratio between two numbers, for example, speed is equal to distance by time, for example, density is equal to mass per unit volume, their harmonic mean would come into play. Quadratic mean. Quadratic mean, the word itself says it is root mean square. That is, we call it as RMS value. Root mean square value, when we talk about standard deviation, root mean square is also used there sometimes. So, it is calculated by square of each value, averaging these values, then taking the square root of these values. Then comes trimmed mean. When I say trimmed, trimmed means we remove the predefined percentage of the lowest and the highest values from the data set. For example, if I say in the morning the machine is completely fresh it is performing really great. Units are being produced and so the nozzles are being produced in one day. In the evening, its performance, let me consider, is going lower. Then whatever goes between 4 to 5 p.m. in the evening, that I am trimming off. That is, I clean the data, that is trimmed mean. Then comes weighted mean. Another way to deal with the data set that is not completely random is weighted mean. I give more weight to the nozzles which are manufactured in the morning time and lesser weight to the nozzles which are manufactured in the evening time if the machine performance is going down from the morning to the evening. That is weighted mean. Then comes combination mean. Combination between any two types of the means. It could be between arithmetic and harmonic mean, it could be between trimmed and weighted mean, so that we try to describe the data more appropriate to our requirements. So these are the kinds of the means. You might have gone through arithmetic, geometric, harmonic means. Trimmed mean, weighted mean, combination mean might be new for you. So here it is a simple data set. It is 10, 30, 40, 20, 50. Mean, we just take sum and divided by the number of observation of 5, the mean is 30. It is a simple calculation. Advantages of mean are, it is the most commonly used measure of location or central tendency. Measure of location is also one of the terms used for measure of central tendency for continuous variables. Arithmetic mean uses all observation in the data set. All observation are given equal weightage, that is, randomness is assumed. When we take mean, whenever we talk about mean, we will generally or always talk about the arithmetic mean throughout this week. Disadvantages: mean is affected by extreme values that may not be representative of the sample. For example, there are students in the class. If I take heights of the students, average height, Indian height is around 5 feet 8 inches. If there is a student who is 7 feet tall, putting that student in the class average of maybe 20 students, the overall average will go very high. Or there could be other way around. There could be one student who is of the height of maybe 4 feet 5 inches, too dwarf, right? Now, here overall averaging of the students of the class is about 5 feet 8 inches. This one student out of the 20 students, if say, would reduce the overall average down. So that means extreme values affect the samples. This is a disadvantage of the mean. Now come mode. Mode describes the most frequent or most typical value. The mode will not always be central value. In fact, it may sometimes be an extreme value. Like for example, 5 feet 8 inches is the average. There could be out of 20, 7 students itself who are having exact height of maybe 5 feet 6 inches. So that is a mode, maximum number of repetition that is there in a set of a sample. A sample may have more than one mode. For example, there are 4 students of 5 feet 6 inches, there are 4 students of 5 feet 7 inches. Both of them are the largest values of the repetition of the number of the heights. So that becomes more than one mode. So data is said to be bimodal. In this case, it could be multimodal. For example, here in this set 4, 4, 6, 7, 8, 4, 9. 4 is repeated 3 times, while other appears only once. Thus, mode is 4. Advantages: it requires no calculations. It represents the values that occurs most often. Disadvantages: mode for continuous measurement is dependent upon the grouping of the intervals. It may not have mode at all. Next comes median. Median is the middle value in a data set that has been arranged in order, separating the upper half from the lower half. If the number of values is odd, the median is the middle term, while arranging the data in ascending or descending order. If number of values is even, the median is the average of the 2 middle values, the data being in ascending or descending order. To see an example quickly, these are the terms 11, 4, 9, 7, 10, 5, 6. So here we see total 7 number of values are there. So the middle value here, while putting it in ascending order, is 7. This is median. So here 1, 3, 0.5, 0.6, 2, 2.5, 3.1, 2.9. The number of values here is 8. So median would be, when you put them in ascending order, the 2 middle terms, that is 2 and 2.5, average of them is the median, that is 2.25. Percentiles or quartiles. Talking about median, we have to talk about quartiles as well. Percentiles are values that divide a distribution into 2 groups where pth percentile is the larger than p% of the values. Some specific percentiles have specific names. For example, first quartile is Q1, second quartile is Q2. First quartile is 25th percentile, second quartile is 50th percentile. Out of the 20 values, when I talked about number of students in the class, 20 students, arranged in the ascending order of the height, or you say the nozzles measurement that you have taken of the diameter, there will be some change in the diameter, some small difference in the diameters. You arrange them in an ascending order. Out of the 100 values, the first 25 number is Q1, quartile 1. Number 50 is Q2, that is median itself. It has been given. Median is Q2. Then 75th percentile, that is before that 75% of the data lies, is Q3, that is quartile. It is QUAR. Quar means 4. Quartile means 4th position. Then we have percent. Cent I said is 100. Percentile, we say it becomes percentile, that means 100 divisions. Similarly, so this all is derived from a common term called as quantile. This quantile could be quartile, this could be percentile, this could be any. We will say 10 divisions, or we may say 20 divisions. So that could also be taken. So this also gives me what is the central location of the data and where we are trying to talk about. Mid-range. Mid-range is the average of the largest and the smallest observation. It is the largest value plus smallest value by 2. From the percentile estimate, mid-range is sometimes taken as 25th percentile plus 75th percentile by 2, that is Q1 plus Q3 by 2. This is sometimes used when there are a large number of observations. So this range is also taken so that we have a better estimate of the mid-range. When I am talking about mid-range, I am still talking about the central tendency only. It is not about range. Range would be the difference between the largest value and the smallest value. That we will talk about when we are going to talk about the measures of variability. Measure of variability, as I talked about, the central tendency is the location of the data, then is the spread of the data. That talks about variability. In the variability, we talk about the range, the variance, the standard deviation. Measure of variability indicates how the observation has spread about the central value, and there are dispersion, there is variability, and these are the measures. Range. The range is the difference between the largest and the smallest value in the sample. The range is the easiest way to measure the dispersion. And to calculate range, we need to just calculate maximum values minus minimum value. In SQC, that is statistical quality control in manufacturing, when we try to see whether our output or the manufacturing that we have done, or maybe the performance of the boiler, or maybe the performance of the turbine that is running is within control or not, we try to plot a chart. The chart is generally sometimes known as, for variables, that is known as X bar and R chart. So here X bar is average or mean and R is range. These are very important charts. So what is the minimum value, what is the largest value, and what is the total difference, what is the overall spread of the data. So this is one of the measures taken for variability. The advantages of range is it is easily understood and gives a quick estimate of dispersion. The range is easy to calculate, only difference between the largest and the smallest value. Disadvantages are range is inefficient because it only uses extreme value and ignores all other available data. Larger the sample size, the more inefficient the range becomes. Then there is a close variability determining parameter that is calculated, which is variance. It is the mean of the squares of the deviations of each measurement from the mean of the population. So there could be variance with respect to mean, variance with respect to median, but generally when we talk about variance, it is always talking about the variance with respect to mean. It is given here. It is from the mean of the population, mean of squares of the deviation. The square values are both positive and negative. Real numbers are always positive. The variance is always positive because it is squared. it is denoted by sigma square. It is calculated as sigma square is equal to summation of xi minus x bar square by n. For population, it is given by mu, where mu is population mean. For sample, x bar is sample mean. Advantage is it is an efficient estimating factor in statistics. Variances can be added and averaged. So, that is why always variance is the most used factor of determining the spread, because variances have additive properties. Standard deviation is under root of the variance. Though the overall degree comes equivalent to mean, we squared the values, we took the under root, degree becomes equivalent, but that cannot be added, that cannot be subtracted. So, these variances can be added and averaged, that is, it has an additive property, that is true, that is why these are used the most. Disadvantage is the calculation of the variances can be tedious without the aid of calculator or computer. But nowadays you use Excel sheet, where simply you have the that relation about the variance, you try to calculate it very directly. Standard deviation is the square root of the variance. It has advantages such as it is sigma, that is under root of the variance. Advantages are it is in the same dimension as observed the value. As I said, the dimension stays same, we took the square, we took the under root. Standard deviation is an efficient estimator. Disadvantages, calculation can be tedious without the aid of a good calculator. Interquartile range, like I talked about range, the largest and the smallest value. Interquartile range, that is the first quartile, 25th value and the 75th value when I talk about percentages. So, 25th percentage and 75th percentage when I talk about quartiles, Q3 minus Q1 is interquartile range. This is also one of the measures of the variability. Now, this is about how do we describe the data. These measures are not only used in descriptive statistics, whatever is being used in descriptive statistics is also used in inferential statistics as well. But in inferential statistics, we add more things. We have hypothesis testing, we have analysis of variance. All these variables or parameters could be used to describe the data. This could also be used to infer about something. Now, descriptive statistics, data, calculations we talked about. Now, let me talk about how do we present the data. To present the data, there could be two forms. That is, organizing the data is done by placing or plotting the compiled data in a tabular form or in a graphical form. The data is generally tabulated in rows and columns, that is subject-wise detailed mark sheets. You see there are columns, we also call them as fields, and we have rows where we have observation, and each of them is known as cell. Graphical form, another form, data is plotted in the form of line or bar graphs. You see these are the bar graphs, these are line diagrams. So, this way data is also presented. It is said an illustration or a figure is worth 1,000 words. You tell a complete story in 1,000 words. For example, you need to see the weather forecast, you need to see what is the scenario of the present manufacturing systems, you need to see what is the present behavior or health of the turbine that is running. You can either write a full paragraphs on that, or you can present that in an illustration, a figure showing this is the growth that is happening, this was the last year thing, and this is the bar graph that is going, this is the line diagram showing the trends. So, that is a graphical form, which is most important thing. How to present the data? Let me first talk about the tabular form. In the tabular form, we have one term known as frequency distribution. The collected raw data is arranged into an ordered array in either ascending or descending way to prepare it for frequency distribution. Numerical data arranged in order of magnitude along with the corresponding frequency is called frequency distribution. Frequency distribution could be ungrouped or group kind of frequency distribution. This I will talk about more when I will talk about normal probability distribution in the next lecture. Let me first talk about graphical representation of the data. In engineering statistics, we make charts, graphs, diagrams to visually display and interpret the numerical data. It eases the user to understand and present the complex information, identify patterns and interpret or communicate insights quickly. The common types of graphical representations include line or bar graphs, pie charts which represents the parts of a whole. If the whole 100% of the population is to be presented, we say this much percentage is correct, this much percentage is other way, then we use pie charts. Histograms for showing frequency distribution of the data, histograms are used. Box and whisker plot for showing quartiles, median, range. Box and whisker plot is there, which is something like this. This is known as box, and these are whiskers. Technically, this is the median or quartile 2, this is quartile 1 and this is quartile 3. This is box and whisker plot. It is generally used when we have line graph. For example, there is data plotted here, we have line graph here and this is plotted like this. And this each point is an average of sum of the observations. Then we can have box and whisker plot everywhere. For example, here we can have, this is the mid value, this is how the whisker is there. This is the mid value, this is how the whisker is there. It depends upon the kind of the thing. The whisker could be at some points very large. At some points, it could be very small even. So, this is box and whisker plot to show the range or the error in each observation. Let me talk about histogram or frequency polygon and what are uses of them. I drew the box and whisker plot here in frequency polygon itself. Histogram, it is a graphical presentation of group frequency distribution, usually similar to column graph. It consists of a series of adjacent rectangular columns keeping on base the class intervals and rising up to corresponding value of frequency on vertical scale. For example, this is serum cholesterol in millimoles per liter and this is a frequency of the occurrence. And this is the largest value, that is between 10 to 11 millimoles per liter. This is the smallest class interval, that is between 3 to 4 millimoles per liter, and maximum number of them are between 5 to 6 millimoles per liter, that is around 25 number of observations are here, and only for instance 3 observations are here, only 2 observations are here. This is frequency, this is the value. Plotting a histogram, mark the class boundaries on the horizontal axis and the class frequencies on the vertical axis according to a suitable scale. With each interval as a base, draw a rectangle whose height equals the frequency of the corresponding class interval. It describes the shape of the data. For a good histogram that should be visible, what do you think? The class intervals to be selected, should it be something so that we get 100 lines? Should it be selected so that we get 500 lines? Or should we select so that we have 4 lines only? There is a range or the number of the stands which should be there in a histogram, vertical stands, that is between in general 7 to 13 bars, or I call it at stands, so that it is visually appealing. Here we have 1, 2, 3, 4, 5, 6, 7, 8. It is visible. If I suppose get 100 bars like this, this doesn't make much sense. It is better to combine them and get a visual data and get about maximum up to 13 bars, so that is visually appealing. The purpose is graphical representation which should be visually giving the shape or the behavior of the data. Line graph or frequency polygon. It is a line graph representing a group frequency distribution here. Class frequencies are plotted against class marks in it. Class marks, if you say here, if the range or the interval is between 3 to 4, the class marks would be 3.5. So, here the class marks between 7 and 8 would be 7.5. So, these are class marks. So, these class marks would give you 1 point now, 1 point here, 1 point here. At each position you get 1 point. So, if you join these points, these class marks, this I am converting my histogram into my frequency polygon. Classes with zero frequencies at both ends are included to complete the polygon shape, that is, it is touched here at the bottom. Steps to draw line graph for frequency polygon. Mark the class midpoints on the axis and the frequency on the y-axis as I just did for the histogram plot. Mark the dots which correspond to the frequency and the marked class midpoints. Join each successive dot by a series of line segments to form line graph including classes with zero frequencies at both ends of the distribution to form a polygon. This is what I did here in blue color. I marked the average values of the class interval, got these points, then I joined these points. This is how from the histogram frequency polygon is constructed. Other than the frequency polygon and histogram, there are the various graphical methods. For example, these are the bar charts. These are the four things. It could be, for example, in a month, week 1, this green is week 2, then red is week 3, then blue is week 4, the total production in these weeks. These are the bars. This could also be stacked bar. For example, week 1 is here, week 2 is here, week 3 is here. Total production of the month, week 1, week 2, week 3, total added over each other. It is vertically stacked. These are bar charts here. Then comes pie chart. I talked about pie chart when we have 100% of the data. Out of the 100% of the data, if we wish to plot it, pie charts could be of many forms. You can see three-dimensional pie chart. You can see pie chart with some pie protruding out to tell specific about that output that we wish to tell about, or that is the point of our interest. Then we have pictograph. In the pictorial form, we can say 25 percentile, 50th percentile, 75th percentile or 100 percentile, how does or where does the data lie. Then we have Pareto diagram that I will talk about in the coming slides. Bar charts. Similar to histogram, a bar chart is a graphical tool that uses rectangular bars to represent and compare data, height of each bar being proportional to the value of it displays. Bar charts can be oriented vertically or horizontally and are ideal for visualizing trends, comparisons, distributions across different groups over time. You see, this is horizontal bar chart, this is vertical bar chart, and which I showed you in the previous slide, these were horizontally stacked, and these were vertically stacked bars. So you see, government, non-profit, foundation, consulting, other, the kind of the people that are being talked about, or we talked about younger, between different ages. This is the way vertical stacked bar is there, between ages less than 30 to more than 60, these many number of peoples are there. Then comes pie chart. Pie chart representation gives a circular statistical graphic divided into sectors or slices called a pie, where each pie represents a part of a whole. The whole population is 100% of the circle. Pie chart shows how total population is distributed across different categories. It depicts a visual representation of parts to whole relationship. You can see heat gain sources in typical Florida homes. Where is the heat gain happening? 30% through windows, 20% through roof and attic. Through walls, it is only 6%. Infiltration is 6%. Internally generated heat is 16%. Duct system heat exchange is 12%. Duct system leakage, that is air leakage, is 10%. It is total 100% of heat that is gained in homes is divided into these different sources of them. Pie charts are most effective when there are a small number of categories and it is needed to show proportions or percentages. When I say small number of categories, it is not always suggested to have a pie chart when we have 100 distributions. For example, for each percentile, each person we have 100 distributions, is not good. Generally, pie chart is drawn when we have more than 3 to maximum 9 divisions, if I say. For example, 2 would be only semicircle. If it is 3, there could be difference between the angles. So, that is between 3 to 9 parts or divisions. then pie chart is used. Pictograph. Pictograph is not something plotted through statistics. It is just showing or having a board, for example, in warehouses. In warehouses, whenever one specific carton is completely filled, they just say, they put the key there. There is a key number for that specific carton, key 1, 2, 3, 4, that is hung up there. This one is complete. And when the supervisor comes, it counts the number of keys. It could be anything, number of tokens. So that is a kind of a pictorial representation of what is the overall status. Total number of 5 cartons of this size, maybe very big size of room size cartons are fixed to be shifted or to be maybe transported out of the factory. This is pictograph. So having roots since 3000 BC, symbols representation has been an effective form of expression in writing. For example, number of vehicles, days of week. This is, let me say, a service station of Hyundai car in the city of Kanpur. In that city, each day when cars come, number of cars being serviced, each time they put one car sticker there, that one car is serviced, second car serviced, third car serviced, fourth, fifth. Here they say one car equal to 5 vehicles. When they put 1, that means 5 cars are serviced, it means. That means 1, 2, 3, 4, 5, 5 into 5, 25 cars are serviced on Monday, 20 cars are serviced on Tuesday. This is a pictorial representation so that the supervisor or the top management could see how and what is the progress of the work. In pictographs, pictures express a word or phrase. In statistics, a key is often included in a pictograph that indicates what each icon or image presents. This is known as a key. One picture is equal to 5 vehicles. All icons in the pictogram must be of the same size, but we can use the fraction of an icon to show the respective fraction of that amount. That could also be possible. Another graphical representation that I would like to talk about is Pareto diagram. Pareto diagram is something when we take or put all the observations in an ascending order and try to see the cumulative frequencies. You see, Pareto diagram is a combination of bar and line graph displaying causes by frequency or impact in descending order. Based upon the Pareto principle, that is 80-20 rule, it helps to identify the vital few issues that contribute most significant to a problem. For instance, this is a plot that shows number of errors which are there during surgical setup. Wrong supplier, excess count, too few count, wrong size, wrong instrument set, missing item, damaged item and others. These are plotted in a cumulative percentage way. Now you see there are few issues out of 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 issues, 3 issues are there which are contributing very high to the wrong surgical setup. And there are 5 issues which are contributing very low. So this is vital few which are identified and useful many which are also identified. That is 20% of the item contribute to the 80% of the problems. 20% of, I would say, reasons. On the other hand, 80% of reasons contribute to the 20% of the problems. This is a Pareto rule. It is not exactly 80-20. Here in this case, it is 3 and 5. It could be 10-90. It could be 30-70. But Pareto rule says this is the way we try to identify what are the vital few issues that contribute most significantly to a problem. The Pareto analysis might include analyzing data to identify errors or defects, sharing information about errors or defects with high priority stakeholders, prioritizing fixes that address the most consequential errors or defects. Had talked about the so much of data presentation methods and graphs. Let me come to an Excel sheet itself. I have taken here data that we plotted or that we saw using the virtual demonstration of the gear pump. So here efficiency is there, and I told you to plot the efficiency with the flow rate. Let me try to use the kind of the plots which are there. Let me see, for example, I have insert tab here. Here we can plot using the recommended charts here, or if I need to have a plot between two columns, I can just select the columns. I am selecting column of flow rate and efficiency, and I will pick a scatter plot here. You see, this is a scatter plot that you can see could be plotted here. On this scatter plot, here we have efficiency on the y-axis and flow rate on the x-axis. This is plotted here. I can also convert this into the frequency polygon. Frequency polygon just like this line, or if you wish to have dots in between the wherever the specific readings are there, I can use another kind of the set. This is frequency polygon. Let me put it here on the side. So, this is a frequency polygon. I could have also drawn an histogram. Let me once again select flow rate and efficiency and try to first have a scatter plot. This scatter plot could be converted to an histogram here as well. You can see here efficiency, histogram with respect to the flow rate, how efficiency is varying. Also, just to show you how to draw a pie chart, a very quick introduction. Let me say, for example, because 100% of data is to be used in a pie chart, let me make a small table here. Let me say in the state and the percentage of pumps. I am talking about percentage of pumps because we are talking about gear pump in a specific area in a state. Let me try to just put some values here. Let me say in Punjab, I am putting percentage is 25%. In UP, let me say 20%. Bihar, let me say 15%. 60 is done. I am going to make total 100. Then let me say Tamil Nadu, 22%, and let me select another state, Odisha. %. This total sum should be 100. Yes, the sum is 100. So, putting this in a table. Now, this data is already selected. I will insert a pie chart here. The kind of pie chart you would like to see, for example, you see here. This is simple two-dimensional percentage of pumps in Punjab, UP, Bihar, Tamil Nadu and Odisha. We can also have this in a little three-dimensional way. I have separated them. I can bring them closer. I can separate them. Any way you like to have taken separate one of the pie. For example, I have separated Tamil Nadu amongst others. Tamil Nadu is given in yellow color. Here is a legend that is given. So, this is simply using Excel, the data presentation you can do. Lot of plots are there. If you see the insert chart, if I come to the recommended charts, amongst all charts there are recent templates, column, line, pie, bar. These are vertical and horizontal bars. The area, XY scatter, map, you can also have stock, surface, radar or a kind of a web kind of a chart that is there. Tree map is also similar to what pie chart got. For example, if I try to draw tree map amongst this, tree map, I will just select this. Okay. Tree map is also very similar to what pie chart is. Tree map is also, it is showing wherever the maximum value is there, 25% is Punjab, it is showing Punjab blue, then Tamil Nadu is 22%, Tamil Nadu in yellow. This is tree map using the same data. I will also plot the same pie chart for you, and this sheet would be provided in the lecture notes. With this, I am recapitulating the first two parts. We talked about the statistics, definition of statistics and role of statistics in research, role of statistics in mechanical engineering, then differentiation between descriptive and inferential statistics. We try to have some examples on certain applications that we saw throughout this course or throughout the series of the courses in the previous sessions as well. Then common limitations of statistics, difference between sample and population in statistics, What are stages in statistical investigation, primary and secondary methods of data collection, and list of the common forms of data presentation. With this, I am closing this lecture. I will meet you in the next lecture where I will talk about basics of inferential statistics. Thank you.